The history of computing devices stretches from ancient abacus, a simple device for mathematical calculations, through the colossal room-sized machines of the mid-20th century, to the sleek laptops and smartphones that have become an integral part of our daily lives. These devices have evolved from manual tools for computation to complex machines capable of executing a variety of tasks at blistering speeds. Yet, the most remarkable leap in this journey is what is happening today. The transition from machines that rigidly follow a set of instructions to those that possess the ability to reason, learn, and make decisions, mirroring the cognitive functions of a human brain. This evolution has ushered us into a new era of generative AI, a technology you might recognize through platforms like ChatGPT. Essentially, it offers intelligence as a service, similar to having a very smart person like Da Vinci, Newton, Tesla, or Sam Altman, or actually all of them combined into one, accessible to you 24/7. Now keep in mind, this is not the first revolution we've experienced. We tamed fire, we learned how to do agriculture, we invented the printing press, steam power, telegraph. These were all revolutionary changes, but they took decades or sometimes even centuries to become widespread all over the world. In this AI revolution, new technology is spreading worldwide almost instantly. This is by far the fastest revolution we have experienced as human beings. For instance, ChatGPT 3.5 is available to anyone in the world for free. All you need is an internet connection. And this is exactly what made ChatGPT go viral, reaching 100 million users within 2 months, an achievement that no other application or technology has ever achieved before in human history. So let's start by taking a closer look at a very basic example of how generative AI models work. If I give ChatGPT, or any other LLM for that matter, a photo of a balloon filled with helium and a needle, and I pose the question, what will happen if I use the needle? Even without being explicitly taught about the dynamics of the needle, balloon, pressure, or air, the model can piece together a coherent and surprisingly accurate response that the balloon will burst. This demonstrates a profound basic understanding of these concepts that we have never ever seen before from anyone but humans. Next, let's set the base by understanding some important terms related to generative AI. AI, or artificial intelligence, isn't some shiny new toy. It's been around for decades. AI was first invented in the University of Toronto in 1980s. The hardware at that time was just not capable to run AI models and train them. But over the years, AI has taken a very fundamental role in our lives. From Netflix nailing your movie preferences, or Facebook seems to read your mind with the relevant ads every time, or even when your bank gives you the green light on a loan request without any interviews. That's AI doing its thing, the old school way, the traditional way. Now enters generative AI, the new kid on the block. This isn't your regular AI. Generative AI focuses on creating new, unique content, moving beyond the traditional roles of searching or categorizing data. This new, unique content is generated through large language models designed to understand and engage in natural human language in the forms humans could understand. ChatGPT, that we all know about now, exemplifies a large language model. Now, to understand the mechanics behind how these bots, the so-called LLMs, can generate such astonishing results, think of large language models like a mini version of your brain. Our brains use neurons to process what we read, see, and hear. Similarly, LLMs use large digital neural networks to process the information provided to them. But neural networks, and therefore LLMs, only work with numbers. So every time you type a text prompt, for instance, you say, "the sky is," this statement gets turned into numbers, kind of like translating English into Morse code. LLMs process the statement to figure out what the next word should be, generates the output in numbers, which then again gets converted back into the text again. And in this case, the output is blue. The sky is blue. Essentially, LLM is a guess the next word machine. Interestingly, I can keep repeating this process. If I send the new complete statement, the sky is blue, the LLM will keep playing the guess the next word game, essentially allowing us to write an entire book starting with just 2 words if you want. It might be a very generic book, but it conveys the message of the ability of an LLM to perform the tasks just like humans do. LLMs do not function by being directly programmed the traditional way with a set of rules and instructions. Rather, they're trained similar to how an infant learns to communicate. Parents don't teach a baby grammar or vocabulary. The kid picks it up through its interaction with the world and keeps improving himself at every interaction. LLMs are trained in a very similar way. We feed them vast amounts of public data from the internet, which it uses to learn and understand the world it is being trained on. In AI terms, this process is called as backpropagation. In this approach, first step is called forward pass, which computes the output from the model based on the guess the next word game we discussed. The output from the forward pass is then compared to the desired output, and then the model parameters updated based on the difference between the desired and the actual output. The next step in this process is called reinforcement learning, which teaches the model to make decisions by trial and error, similar to teaching a baby good and bad behavior. The LLM, like the baby, learns from rewards, cheers or claps, and punishments and warnings, mistakes, gradually learning to distinguish between good and bad actions, improving its ability to complete specific tasks. This process required thousands and thousands of hours of manual human intervention and feedback, providing the reward and punishment to the LLM on every task it completes. It is because of reinforcement learning that a model like ChatGPT won't teach you how to build a bomb. It very well knows how to, but through reinforcement learning, it has been taught by humans that making bombs is a bad thing, and therefore it should not teach it to humans. LLMs can further be trained to perform exceptionally on a subset of tasks through a process called fine-tuning. Fine-tuning is a technique to further train an LLM model, a model that has already been trained on a large dataset, on a smaller subset of a specific task dataset. This process adjusts the model's parameters to adapt it to a particular task or dataset. It's like customizing a general tool to perform a specific job more efficiently, leveraging the broad knowledge it already has and applying it to a more focused problem. This is what most of the AI SaaS tools are doing out there today. AI lawyers, AI girlfriends, AI doctors, and so on and so forth. GenAI models can further be divided into subcategories based on the type of the input prompt they take in and the output they produce. Starting with the most popular ones, models like ChatGPT-4 are text-to-text, converting textual inputs into outputs. This includes not just conversational language, but also structured data such as code from Java or Python, for example. Personally, I find these invaluable for coding as they not only save time, but also enhance my learning through the code they produce. For creating visuals, text-to-image models come into play. Simply describe your vision, choose a style, and receive your image. Image-to-image models offer capabilities like editing or merging different images together. Image-to-text models, on the other hand, provide descriptions of images, while speech-to-text models are perfect for transcribing audio like recording meeting minutes. Text-to-audio models can produce soundscapes or music based on a prompt. For instance, the sound of a bustling cafe can be synthesized on command. Video generation is possible too now, with the latest one being Sora AI, that creates ultra-realistic videos from just text prompts. Text-to-video models could potentially create endless series of movies that evolve according to your preferences in real time. A thought that's both fascinating and a bit daunting, honestly. Another trend that has popped up now is multimodal AI solutions, integrating various models into a single platform for handling text, images, and audio seamlessly. An example is the ChatGPT mobile app, where I amusingly asked how often do I need to water this plant, and it came back with the exact instructions by identifying the plant type and how to take care of it. Now, if we further deep dive into the landscape of text-based large language models, several open and proprietary models have gained popularity due to their diverse applications in natural language processing, content generation, and more. Among these, ChatGPT is celebrated for its conversational prowess, with the highest critical reasoning ability among all models out there. It offers multimodal capabilities, including image generation, advanced analytics, which provides access to 2,000 Python libraries within the ChatGPT interface, no-code AI agents to perform specific tasks based on a set of instructions and knowledge base, similar to the concept of fine-tuning we discussed before. Bard by Google is recognized for its accuracy and reliability, particularly in generating factual and informative content. Although it has come under some controversy due to the wokeness of the model, it does allow seamless connection to the Google Suite, including Drive, YouTube, Maps, Hotels, and Flights, to name a few, something that ChatGPT lacks. Claude by Anthropic, on the other hand, is noted for its ethical use of AI and slightly lags behind ChatGPT as the second best model on Hugging Face leadership board behind ChatGPT. It also boasts about its high context window, which in layman terms means it can accept an entire book as an input prompt, while ChatGPT and Bard input prompts are restricted to a few thousand words. Something that I've picked up after teaching 10,000 students AI-related courses on Udemy. It's like people are sorting themselves out into two teams based on how they feel about AI. On one end, there's the no way not happening camp. Folks who reckon AI is not touching their job, or they're just too swamped with their own work to even peek at what AI is all about. On the other extreme, we have got the doom and gloom crew, drowning in the fear that AI is going to sweep their job or send their business packing. In my perspective, sticking to either of these mindsets is not the brightest idea. So here's a thought. Why not find a sweet spot? A cool, collected stance where you see AI as your secret sauce, turbocharging you. From my corner, adopting AI means nothing short of magical. It's like I've unlocked some next level abilities to increase my productivity by at least 10 times. AI is the ultimate genius buddy by your side 24/7. To be able to utilize the power of LLMs to their full extent, mastering the art of prompting is the key. In its simplest definition, a prompt is the input you send to the model to do a specific task. In this context, if AI is the genie in a lamp, prompt engineering then is the art of asking the right questions to make the genie work wonders for you. You might have noticed how some of your prompts lead to an overly generic response, while others precisely hit the mark. This is because it's not just about what you ask, but how you ask it. A simple write a story yields something very generic, but ask for a sci-fi story set in 2040 about a robot rebellion and the magic starts to unfold. Hence, precision is key. Vague prompts will always lead to vague results. But when you tailor your prompts with specifics, context, and clarity, the AI can produce remarkably targeted outcomes. In a landscape where AI is transforming everything from art to business, mastering prompt engineering can be the difference between a mediocre result and an astonishing one. So how do one get astonishing results through prompting consistently? You achieve this by using a combination of the following components correctly and in the right order, depending on the task at hand. And they will drastically improve the quality of the responses you get from AI. First of all, start with defining the task at hand. Begin your prompt with an action verb, generate, analyze, write, and be crystal clear about your end goal. This clarity is crucial whether you're asking for something straightforward, like a 3-month training plan, or something more complex involving multiple steps, like coding for building a website. Context is next. It might be tempting to provide a lot of background information, but it's more effective to focus on what's truly relevant in this case. Ask yourself 3 questions to guide this process when talking with AI. What background is necessary here? What does success look like in this scenario? And what's the environment that I've put the LLM bot in? This approach helps you give just enough information to guide the AI without overwhelming it with information. Examples are incredibly powerful. Including examples in your prompts can dramatically improve AI's output, making it more tailored and effective based on your job. Whether it's rewriting a resume or preparing for an interview question, examples act as a clear template for the AI to follow. The persona component lets you specify who you want the AI to emulate in its response, whether you need advice from a physical therapist or legal guidance from a lawyer. Defining persona makes the AI's responses more relevant and insightful to your specific situation at hand. Formatting is another key aspect. By visualizing exactly how you want the output to be it a table, a list of bullet points, or a structured document, you guide the AI to produce responses that are ready to use and fit your specific needs. Lastly, consider the tone. Specify whether you want a casual, formal, angry, or enthusiastic tone, as it can significantly influence how the response is perceived. This is particularly useful when you want the content to match a certain vibe or for a certain specific audience.